Welcome back, guys. I hope you enjoyed the last video where we introduced how to do integration by substitution. Today we're going to do some more examples that are a little more challenging than the ones you did in the last video. And on the last slide, you'll have some chances to practice on your own and see how you did. Don't forget to see me during office hours if you're stuck. So we know that the main steps for U substitution is to look for something to be the U, and usually you pick the inside to be U. So let's look at this first example here. This right here is going to be my inside. So I'm going to let U equal x squared plus 2x plus 5. Then I take the derivative of that. Du dx is 2x plus 2. The next thing I need to do is solve for dx. So I'm going to multiply dx on the other side and then divide by 2x plus 2. So now I have a substitution. I'm going to put all of this in for dx, and I'm going to replace the x squared plus 2x plus 5 with a u. So now my integral is u to the 5th. My 2x plus 2 is still there. Du over 2x plus 2. Then what happens is the 2x plus 2's cancel, so I'm left with the integral of u to the 5th du. Well, the integral of u to the 5th is u to the 6th over 6. And the last thing I need to do is plug u back in. So that's x squared plus 2x plus 5 to the 6th over 6 plus c. And that's your final answer. The next example is similar. So I'm going to let u equal x squared minus 3x plus 7. I'm going to take the derivative of u. So du dx is 2x minus 3. And I'm going to solve for dx. So now I'm going to multiply by dx and divide by 2x minus 3. So I can substitute all of this for dx and all of this for x squared minus 3x plus 7. So now I have the integral of u to the 4th, and then replace dx with du over 2x minus 3. Well, the 2x minus 3's cancel, and I'm left with the integral of u to the 4th du. Well, the integral of u to the 4th du is u to the 5th over 5, and we can plug u back in. X squared minus 3x plus 7 to the 5th over 5 plus c. So just to recap the things that we substituted in, I'm replacing all of this with u, and I'm replacing dx with this du over 2x plus 2. The 2x plus 2 that was already in the equation didn't change. This 2x plus 2, there was nothing to substitute. That stayed the same. The yellow is the actual substitution that I did, and that will make sense, or that will be more important in these next examples that we do. So now we have e to the 5w. So 5w is my u, and the derivative of that notice how I have du dw now instead of du dx. The derivative of 5w is 5. I need to solve for dw. So du equals 5 dw and I'm going to divide by 5. So dw equals du over 5. So now I can do the substitution. E to the u, and then du over 5. Well, I have this random constant now that doesn't cancel. So what I'm going to do is rewrite this as e to the u 1/5 du. And then use the rule that we learned in the last section that constants can be taken out and rewrite my integral as 1/5 integral e to the u du. And we know how to take the integral of e to the u, it's just e to the u. So now I have 1/5 e to the u plus c. The last thing I need to do is plug in 5w back in. 1/5 e to the 5w plus c. So nothing canceled here, but I had a constant left over that I could pull out. You can't have leftover variables. You can only have leftover numbers. So it either all needs to be w or all needs to be u. You can't have u's and w's or u's and x's in the same equation. So let's apply that to this next example here. I've got x e to the negative x squared. So I'm going to let u equal negative x squared. So du dx, and I just remembered the dx is missing there. Du dx is negative 2x. And I'm going to solve for dx. So du equals negative 2x dx. So dx equals du over negative 2x. And now I can do my substitutions. The integral of x e to the u du over negative 2x. So the 2 doesn't cancel, but these x's do cancel. And so now I have the integral e to the u du over negative 2. I'm going to rewrite this just so I can see what constant to take out. E to the u negative 1/2 du. And then I'm going to use my constant rule. I can take this out front. So now I have negative 1/2 integral e to the u du. The integral of e to the u is e to the u. So I have negative 1/2 e to the u plus c. And the last thing I'm going to do is plug back in what u is. Negative 1/2 e to the negative x squared plus c. Alright, so let's take a look at these. We've got underneath a square root, so that's usually going to be your inside. But the first thing I'm going to do is rewrite this as 4x squared x cubed plus 5 to the 1/2. I don't want to have square roots in there. So I'm going to let u equal x cubed plus 5. So du equals 3x squared. And I'm going to solve for dx. So du equals 3x squared dx. I can divide both sides by 3x squared. So du over 3x squared equals dx. So I have my u and I have what my dx is. So now I can do the substitution. So I've got my 4x squared still there. But instead of the x cubed plus 5, I'm going to put u to the 1/2. And instead of dx, I'm going to put du over 3x squared. The x squareds cancel. And I have this fraction 4/3 right there. So I'm going to rewrite this as the integral of 4/3 u to the 1/2 du. and I can take the 4/3 out. And now I can take the integral of u to the 1/2. So remember, I add 1 to the exponent. And when I have fractions, the easiest way, instead of dividing by the new exponent, I can multiply by the reciprocal. So now I have this 4/3, and then I have u to the 3/2, and I multiply by the reciprocal. And so now I have 8/9 u to the 3/2 plus c, and I can put u back in, 8/9 x cubed plus 5 to the 3/2 plus c. Alright, so these are the hardest ones you're going to come across. So if you can handle these, you can handle any of the u substitution problems we're doing. Let's take a look at this last example, and then you'll have some time to practice some on your own. So I'm going to let the denominator be u. So I'm going to let u equal x squared minus 9. So du dx is 2x. Solve for dx. And now we can do our substitution. So I have x over u, and then I have du over 2x. So the x's cancel, and I have this 1/2 left over. So I'm going to rewrite this as 1/2, then I have 1 over u and my du. I'm going to take the 1/2 out, 1 over u du, and we're going to use our integration rules. We know the integral of 1 over u is natural log of u, so this is 1/2 natural log of u plus c, and the last thing I'm going to do is plug back in 1/2 natural log of x squared minus 9 plus c. So now I want you to give these 7 examples a try. So press pause here and give these a try, and then when you hit play, you'll be able to see the answers. Here are the answers to the first 2. Pause here to see the answers to 3 and 4. Pause here to see the answers to 5 and 6. And here is the answer to number 7. So make sure that you're keeping up with your work and seeing me during office hours when you have questions. You can re-watch this video, rewind, or pause anywhere in the video to make sure you have good notes. And don't forget to practice your Math Excel problems. See you next time.